now we're going to continue with Bob Reed. He is a professor of economics at the University of Canterbury, where he researches applied econometrics and meta-analysis. Bob, if you could start sharing your screen.
Sure. So let me kind of get organized here. All right. So I think Tom started his talk by wishing everybody a good evening, and I'm going to start by wishing everybody good morning. So I'm in New Zealand, and we're 3 hours earlier here. So we can all try to stay awake together. This paper is joint with Tom Coupé, and he's a colleague of mine at the University of Canterbury, and we're both associated with a research cluster called UC Meta. And the topic that we'll present today is trying to address the question, do negative replications affect citations? Do a number of things in the paper, but the particular question I want to focus on this morning is, does a negative replication, that is a replication that does not confirm the findings of an original study, affect the citations of that original study more so than, say, a positive or a neutral replication? To do this analysis, we need a couple things. We need to have replications. We need to have assessments of those replications. We need to determine whether those replications supported or disconfirmed the original studies. We need to pair the replications to those original studies. And once we've identified that set of original studies, we need to match those two controls. So basically, we've got 3 sets of studies, and we want to compare citations for each of them. First, we're going to have original studies that received negative replications, and then we're going to have original studies that received positive or mixed replications, and then we're going to have our controls. So to get our replications, we're going to go to 2 sources. The main source is Replication Wiki, the website that Jan Heffler manages. And to a lesser extent, we'll pull some studies from the Replication Network, which actually draws most of its replication studies from the Replication Wiki. We don't select a subset of those replication studies. We choose all the ones that appeared on those sites that satisfy some criteria we have for what constitutes a replication study. So that's where we're drawing our replications from. In determining whether a replication was a positive or a negative replication, we decided to take the author of the replication study's own assessment. So these are some examples. I'm not going to read through them, but basically most replication studies, either in the conclusion or the abstract, will summarize their findings as either supporting or disconfirming the original study. We decided to do that as opposed to giving our own assessment because, well, first of all, that would be subjective if we did the latter. We also really care about the perception people have of the replication study. And my guess is the author of the replication study can best control that perception by the spin they put on their results. And so basically, that was our strategy, to take the author's own assessment as whether or not the replication study confirmed or disconfirmed the original study. So the flow chart looks like this. Grab our replications from Replication Wiki and the Replication Network, pair those up with the original studies, and then find controls that we can match to those original studies. And to do that, we have a 2-stage process. So the first stage process is we find for any given original study, we go to Scopus and we find all studies that were published in the same year, in the same general area as the original study, and in the same set of journals. Not necessarily the same journal, that would make it too narrow, but the same set of journals in which our original studies were published. So we try to hold constant journal quality that way. So that identifies a large pool of potential control studies. And when we do that, we get 112,000 potential controls, and we've got a total of 204 original studies. Okay, these of course are all from economics. That's our first stage. And then in our second stage, what we're going to do is look at the citation history, that is the citations prior to the replication being published, so the pre-treatment period. And we're going to look at two dimensions: the years difference between the time period, the year when the original study was published and the replication study was published, so that gap, which identifies the citation history prior to the replication. And then the second issue will be the number of citations that the original study had at the time the replication was published. So looking at the first dimension, that gives you an idea of the distribution of years between when the original was published and the replication was published. So we want to match our controls to have the same time period, the same citation history. So we're going to compare citations over exactly the same time period for our control and our original study. And what you see here is that most of our studies, original studies, were replicated within a few years of originally being published. And so we're going to set a minimum pre-treatment period of 3 years. And most of our studies will have 5 years or less. So that gives you an idea of the distribution for the citation histories that we have. And the second dimension we want to measure on or match on is the number of citations that the study had at the time the replication was published. And once again, we have a wide diversity. This again is our 204 original studies. And most of these studies have 50 citations or less at the time the replication was published. Okay, so those are our two basic matching criterion. And now we want to go about the business of finding good controls for our original studies. So here's an example. So here we have a 3-year gap between when the original was published and the replication was published, which gives us 2 full years in between to compare citations. And so what we look at is at the number of citations for the original study and for the control for each of those intervening years. And we calculate then what we call the total absolute difference. That's taking the absolute value of the difference in citations for each of those years between the original and the control. So that's what it looks like for a 3-year period. For a 4-year period, same idea. Now we have 3 years of citation history to compare the original and the control. We take the absolute difference between the original and control citations for each of those years, sum it up, and so now we have a measure of total absolute difference for all those studies that have a 4-year gap between when the original and the replication were published. Okay, so that's our key measure for measuring closeness, total absolute difference. And what you'll see is that if we want to have perfect matches, then that's where the total absolute difference is going to be 0. That means for every single year of the citation history in the pre-treatment period, the number of citations for the original and the control were exactly the same. Problem is, we're not going to find that many perfect matches. All right, so that's half of the equation. Half the equation is measuring closeness. And then the other half of the equation is you want to be able to determine how close do we have to be to match the controls to the originals. And so we're gonna set that caliper based upon the number of citations at the time, the number of citations of the original study at the time the citation was published. Okay, so we're going to go over that same citation history, that pre-treatment period, count up how many citations the original study had at the time the replication was published. All right, and so here, same picture. Now we're just looking at the citations of the original. And what we're going to do is we're going to match the control with the original if that difference in citations in the pre-treatment period is less than or equal to some threshold. And that threshold value is going to be a function of how many citations the original study had at the time the replication was published. The idea being that it's hard to find good matches. It's going to be a lot easier to find a good match if the original study didn't have that many citations, because most papers don't have that many citations. But when the original study has a lot of citations, well, we're going to have a little looser matching criterion there. And what determines the looseness of our matching criterion is this parameter here, the percent. And so that percent is going to take values between 0, 10, and 20%. And as that percent gets larger, the caliper gets bigger, and we allow more matches. Okay, so that's our matching strategy. And honestly, that's I spent a lot of time on that because I think that really is the key part of the paper, is how we choose our controls. Okay, so what does that caliper look like? Well, when the matching criterion is 0%, that's what I got up here, okay, in that first column. What that says is no matter how many sites the original study had at the time the replication was published, we're not going to allow a control to be matched unless it has one or fewer, unless the number of citation differences it has is one or fewer. Didn't say that very well. The differences can't be more than one. There can't be a difference of more than one citation over the entire pre-treatment period. Well, that's a very strict matching criterion, okay? The second matching criterion is 10%. And here we loosen it up a little bit, depending on how many citations the original study had. So when it only has, say, 50 citations, we'll allow all matches where the difference in citations over the entire pre-treatment period is no more than 6. But if we get to 1,000, and we do have a few of our studies with 1,000 or more, we'll loosen it up yet further, and we'll allow matches that have no more than 100 difference in citations, and again, larger yet for 20%. Okay, so that's how our caliper works in setting these matches. Okay, we do that for every measure of gap year. So when we have 3 years intervening, or 4 years intervening, or 5 years intervening, the sample we're going to focus on is when we lump all those together, and we have between 3 and 8 years difference between when the original was published and the replication was published. And that gray band tells us how many originals we have and how many controls. So when the matching criterion is 0%, then in that case, we're going to have 74 original studies and 7,044 match controls. And you can see when we loosen up the caliper here, we increase our number of originals to 103 and number of matches controls to 7,552, and so on. Okay, so those are the samples we're going to look at and the examples I'm going to give. So how well do we match? How close is a typical match? Well, when the matching criterion is 0%, by definition, you can't deviate by more than 1 citation over the entire pre-treatment period. And the median difference is 1. We have a very large percent of matches that are perfect matches. And the mean difference over the entire citation pre-treatment period is 0.7, okay? And again, as we loosen that matching criterion, this shows you how close the matches are. The median is 1 in all 3 cases, but as we loosen the matches, we get larger and larger differences at the tail end of the distribution. But still, even with 10% of a matching criterion, 99% of our matches differ by 3 or fewer citations over the entire pre-treatment period. Okay, so here's our key equation. Again, we do a number of things in the paper, but I'm just going to focus on this because of the time. This is basically a difference in difference equation. So the dependent variable is going to be the difference in citations between the original and the control. And on the right-hand side, we're going to have this variable, this dummy variable called refute. That's going to take the value 1 when we have a negative replication. That is a replication that does not confirm the findings of the original study, okay? And we're going to estimate that regression for every year over a window that includes 3 years prior to the replication study, the year of the replication study being published, and 3 years afterwards. We also do it for 5 years afterwards, but I'm just going to focus on the 3 years again because of the interest of time. So we do these individual year regressions, and then we're going to pool them to address some of our hypotheses. But initially, it's going to be individual year regressions. And again, we're going to pool our samples to include all matches which have citation histories that run from 3 to 8 years between when the original was published and the replication was published. Okay, so that's the setup. And the key thing to note is that coefficient in front of the refute dummy variable, our treatment variable. Okay, so what does that coefficient tell us? Well, effectively, in this difference in difference setup, it tells us the how many more or fewer citations original studies with negative replications received compared to original studies with positive or mixed replication. We'll say that again. That coefficient is going to tell us a numerical number. It will tell us the difference in citations from original studies that got negative replications compared with original studies that got positive or mixed replications. Okay, so this is one set of the results. Again, we have lots of different ways we do this. The particular estimates I'm going to present here come from a quantile regression, and these represent 3 separate regressions for the 3 matching criterion, and 3 sets, I'm sorry, because these results are each a separate regression for each of the years. All right, so up on the top are my 3 matching criteria, and then the top panel represents the yearly regressions for the 3 years prior to the treatment. The next panel down here represents the individual year regressions for the 3 years of the post-treatment period. And as a point of comparison, I also include the mean and median citations of the original studies at the time the replications were published. Okay, so let's go ahead and look at what these numbers mean. So here's, again, just one number. This is looking at the closest match. So this is the case where the controls and the treateds, the original studies don't differ by more than 1 citation over the entire pre-treatment period. And this is the estimate for the year after the replication is published. So it's looking at that difference 1 year after the replication is published. And the estimate says that original studies that received negative replications got 0.045 citations more in that year than original studies that received positive or mixed replications. Okay, so that's 1 year after the replication was published. This number is 2 years after the replication was published. And we find here that studies that received negative replications got about 1.7 citations more in that year compared to studies that received positive or mixed replications. And again, what we'll do now is we'll go ahead and we'll sum over the post-treatment period. All right, so the numbers here represent the sum of the treatment effects in the post-treatment period. And in this case, that first column is the closest matching criterion, the matching criterion of 0%, again, where controls and originals don't differ by more than 1 citation in the pre-treatment period. And we find that approximately over that 3-year post-treatment period, that studies that received a negative replication got 2.5 more citations than studies that got a positive or mixed replication. So again, what was our prior? Our prior that we'd expect to see a negative sign there. We'd expected to see perhaps had you read the literature a little more carefully, I became aware of Tom's paper actually after seeing it on the agenda here. We expected to see that coefficient being negative and indicating a citation penalty for papers receiving a negative replication, but in fact the coefficient is positive. How big is it and significant at the 10% level? How economically significant is it? Well, if you compare it to the original studies at the time the replication was published, the mean number is about 8, the median number is about 5, and we're estimating a treatment effect of 2.5. So it's not inconsequential, it's not huge, but the main point is it's not negative, it's positive, okay? All right, so that gets us to our conclusion. Again, a lot of results in the paper, but the bottom line and the most important question that we addressed was we find no evidence of a citation penalty for negative replications. Okay, that's the end of my talk.
Thank you very much, Bob. There are several questions in the chat, and we have still 4 minutes or three minutes. So Joel is suggesting, would it make sense to use synthetic controls in this context? An idea that may or may not make sense is papers that are frequently co-cited with the replication.
A synthetic control. So we had thought about that. And to be honest with you, my co-author is sort of the matching whiz here. I think we felt that it was better to find, since we could find good matches, that we could make sure satisfied the criterion of no trends prior to the treatment. We felt this was a better strategy, but I'm open if somebody were to say constructing synthetic controls would be better. I'm open to understanding why they think that's the case.
Yeah, I guess I was just thinking that you have potentially a lot of controls that match reasonably well in the pre-period, and maybe averaging over them would do better or be in in the sense of like if you select it, like say that there's multiple papers that match, multiple potential controls that match exactly in the pre-period, like using the average might be better than picking one.
Okay, so I got you. So actually, the typical original study has, I don't know, multiple hundreds of controls. So some of our regressions are basically treating every match as an individual observation. Some of our regressions, like the one I just showed you, does in fact take the average of the controls. And so that difference is a difference between citations of the original and the average of the controls that are matched with it. So we actually do that both ways.
I think we have time for one more question. Jason has his hand raised. Jason?
Thank you, Fernando. Really interesting study. I'm wondering if you can dig more into what these citations look like, doing some maybe textual analysis to see, is there like a more negative connotation around that paper that was not replicated? I think that's one way to think about it. And then there was a comment about kind of, papers that are cited together. And if in particular, kind of after the negative replication, if any, what's the incidence of citing the replication study alongside the paper that failed to replicate?
Yeah, I think it actually really highlights the difference in Tom's approach and my approach. So Tom did an amazing job of going through the actual studies and counting up how the replication studies were and how the citing papers were handling that. We would have too large a number. We'd have to use a strategy like Tom did to go ahead and identify a small subset that we can go deep and narrow like he did. The one thing I would say here that I think is worth pointing out, Tom focused on really egregious replication studies that pretty much, I think, closed the door on the original study in terms of being very large samples. I think there might actually be different processes in place for kind of super studies that receive a lot of attention and sort of more run-of-the-mill studies that you know, are, as you saw, most of the studies in our sample, the original studies, receive 50 or fewer citations. And so I think that's in some sense more typical. And if you believe in self-correcting science, I think in some sense that's the more important case than the super cases that receive a lot of attention because, well, there just aren't that many of them, and they're not representative of how all of science works. But I do think there's different processes at work that are worth exploring.